All right, here we go with the next page. It says, write the inequalities that are represented in the graphs below. So we have multiple different ways we can do this. If we wanted to do it by hand, we would have to look at our y-intercept, which is 6. So let me get my 6 in there. And we need to figure out my slope. It's positive 6, first of all. Positive 6. Rise over run. I need to find 2 good points. So first of all, we got a point right here. We have another good one at, it looks like 2, 7 would work. You have a good point at 4, 8, that would work. So you have multiple points that'll work. You only need 2. So let's say I use this one. Make my triangle, do rise over run. My rise is 1, my run is 2, and my line's going up, so it's positive. So we have 1/2 x. Because this is an inequality, we need to figure out, first of all, if it's less than or greater than. Well, if I'm shaded above the line, we're going to want greater than. If it's a solid line, we want greater than or equal to. So there's one way you can do it. Second way you can do it is using our squiggly line. You can always do an XY table. Pull 2 good points. So let's say we picked, let's use the same 2 points, 0, 6, and let's say you did 2, 7. Then go use your Y1 squiggly line, X1 plus B. I'm going to show you we're going to get the same answer. Oh. Okay. So go to my calculator, plus sign table. We're putting in 0, 6, 2, 7, Y1 squiggly line, X1 plus B. So my M is 0.5. I'm going to type in 0.5 and then click on the fraction button. So it's 1/2. So write that down. M equals 0.5, which is 1/2. My B equals 6. So if I'm writing my equation, there it is. We would have our y. I'm going to leave a blank there for now. We have 1/2 x plus 6. And then you have to do the same steps we did before. Did we shade above or below? Above, so it's going to be greater than. If it's a solid line, it's going to have or equal to underneath. So you either do it by hand or calculator. Up to you. Here we go on the next one. So we can do the same thing. If I want to do it by hand, well, my y-intercept is at -1. And I need to find 2 good points. So there's one good point. We could always do another good one at, let's see. So like right here, for example, 2, -6 is a good point. Remember, when you're looking for a good point, you're looking for it perfectly hits the corner of the grid on your graph. So for example, another good one could be where? Like, let me see, what's this one? -4, 9 could be another good point. So you got multiple different places that we can go for points here. Oh gosh, my nose. So we can either do rise over run, like we did over here to make our triangle to figure out our slope, or you can use your table, whichever one you prefer, x, y. We know for sure we got the point 0, -1. And we said we got the point, we went, you see. Is that even a good point, y'all? Because if I go up 1, 2, 3, 4, 5, and right and left 2, if I follow that pattern, up 1, 2, 3, 4, 5, left 1, 2. Okay, it is a good point. Okay, I checked my pattern. So if I did your triangle, so you can either do it like this or you can do it on the bottom. Either one. Your rise is 1, 2, 3, 4, 5. My run is 2. It's negative. If you did your rise over run, it would be -5 over 2. So if I'm writing my equation here, by, it would be -5 over 2x. Our y-intercept is -1. Well, did I shade above or below on this line? I shaded below, so we want a less than sign. If it's a dashed line, do we want our or equal to line? No. So there's our answer. Even if we did it in our calculator, we would get the same answer. If I put in 0, -1, and let's say, for example, 2, -6, and then use my squiggly line, y1 squiggly line, x1 plus b. So we said 0, -1, and 2, -6. So we got my here. Did I? Oh, 0, -1. What the heck? 0, -1. 2, -6. Use my squiggly line. So I got -2.5. If I change that into a fraction, -2.5, click the fraction button. I get -5/2, which is exactly what we got over there. And I got my y-intercept is -1. So same equation, just two different ways, either calculator or by doing it by hand. Sliding down. 47 says circle all the solutions that are included in the solution set of 3x minus 2y is greater than 12. They purposely did not give you a graph. There's no graph here for you to graph it and then try and shade it in and see which ones are in the shaded area. They didn't give it to you. We got to do this by hand, which y'all are whiners when we do it by hand. And it's not even hard because I say it by hand, but it's also technically calculator as well. So we have 3x minus 2y is greater than 12. So here's what I'm going to do. I'm going to do 3 parentheses. Instead of x, we're going to put 4. So 3 times 4 minus 2. Instead of y, I'm going to put 8 is greater than 12. And then I'm going to plug this in my calculator, see what I get. Let me clear all this. So it's 3 parentheses 4 minus 2 parentheses 8. I got -4. So I have -4 is greater than 12. Is -4 greater than 12? No. So that won't work. So now I'm going to try it again with 0, 0. So back to my equation. So it's going to be 3. Instead of x, we're going to put 0. So 3 times 0 minus 2 times, instead of y, we're going to put 0 is greater than 12. Plug this part in my calculator, see what I get, see if it's true. So I'm going to go here. I'm going to change it to 3 times 0 minus 2 times 0. And I get 0 is greater than 12. Is 0 greater than 12? No. And then we just rinse and repeat. So once again, here's our equation. So I'm going to put down 3. Instead of x, I'm going to put 2 minus 2. Instead of y, we're going to put -3 is greater than 12. I'm going to go plug this part in my calculator, see what I get. So I'm going to change this to, well, didn't help. Okay, so 3 times 2 minus 2 times -3. So I got 12. Is 12 greater than 12? No, they're equal to each other. This one's out. Now the same thing with the next one. Starting with our equation. So 3, instead of x, I'm going to put 0. Minus 2, instead of y, I'm going to put -9 is greater than 12. And see if I get a true statement. So now I'm going to plug in this part, see what I get. So it's going to be 3 parentheses 0 minus 2 parentheses -9. I get 18 is greater than 12. Is 18 greater than 12? Yes, so that one works. All right, so double check our last one. I'm going to kind of squeeze it in over here. So we got Start with my equation, 3. Instead of x, I'm going to put 8 minus 2. Instead of y, I'm going to put 2 is greater than 12. And I'm going to plug it in. When I say plug it in, I'm plugging in this side. See if it's greater than 12 or not. So I'm going to do 3 times 8 minus 2 times 2. All right, so I got 20. Is 20 greater than 12? Yes. So this is also an answer. Okay, I'm going to scoot down. Here's what I got for 48. It says graph the system of inequalities and then answer the questions to the solution of the system. I'm going to go grab 2 different color highlighters. BRB. Okay, I got 2 others. We have here y is less than negative 2. So first of all, let's talk about what we know. If it is y is less than 2, is it going to be shaded or dashed? Hopefully you said dashed because it's not or equal to. And if I want less than, are we going to shade above or below? Below. Okay, so y is less than negative 2. So on my y-axis, I'm going to go to negative 2. There's no other information. And I'm just going to put a dashed line on there. So y is less than negative 2. And I'm going to shade, we said below. So let me get that shaded in there. And for the next one, it says x plus y is greater than or equal to 1. I'm going to go ahead and change this to slope-intercept form and get the y by itself. We have x plus y is greater than or equal to 1. To get the y by itself, we need to move our x. The opposite of a positive x is a minus x to both sides. So we have y is greater than or equal to negative x plus 1. So here's what we know from this equation here. First of all, if I'm looking here, so now that we've converted it, do we have a solid or dashed line? Solid because it has or equal to. If it is greater than, are we going to shade above or below? Above. I'm also going to write down, what is our slope? What's the number in front of my x? It just says negative x. Remember, if there's no number in front of your x, there's an invisible 1 there. So our slope is negative 1. My b, my y-intercept, is positive 1. So where I'm going to start? I'm going to put a point on my y-intercept, which is at positive 1. My slope is negative 1. So if you think of it as rise over run, that would be negative 1 over 1. That means we're going to go down 1, right 1, 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 and so on. I'm going to go ahead and take my badge to use it here. We are making a solid line. Let me try as best I can to get it in there. And we said we're going to shade above that line. Remember, if we have 2 inequalities on the same graph, what we are doing is we are paying attention to here, which is this double shaded area. We want the double shade. Okay, so is there a solution set? So that means, is there an area that is double shaded? Yeah, that's right here. This is our double shaded area. Is 0, 0 included in the solution set? So if I put a point right here at 0, 0, is that in our double shaded area? No. So list one point that's included in the solution set that is not the origin. So you can give me a bunch of different points, as long as they're in the double shaded area. So for example, 6, -3 would work. For example, 4, 8, -4s doesn't really matter as long as it is something that's in the double shaded area. And remember, you cannot touch a dashed line, but you can touch a solid line. So for example, 8, -7, that would also work as well. Because even though it's not exactly in the double shaded area, it is on my solid line next to the double shaded area. So don't give me a dot that is on the dashed line. It has to be in the double shaded. You cannot touch a dashed line. All right, for this one. Nice, they're already in slope-intercept form. The y's are already by themselves, so that saves us some work. If I'm looking here, my y-intercept is 5, so I'm going to go ahead and put a point on 5. Once again, if there's no number in front of my x, there's an invisible 1 there. Here's what we know. If it is greater than or equal to, it's going to be a solid line because it has a or equal to. And if it's greater than, we're going to be shading above. Okay, so our slope for that first line is -1, which is kind of like the other one. Rise over run would be -1 over 1. So it means we're going to go down 1, right 1, down 1, right 1, down 1, right 1, and so forth. And we said solid line, so I'm going to take my badge, use that to make my solid line. And we are shading above. Oh, I didn't even mention that this is the green one. What is wrong with me? Okay. So if I'm looking here, we're shading above, so I'm going to shade above that line. Okay. Here's what we know about the next one. Next one, we know we have a y-intercept at -3. Bam. Just put my point on -3. If there's no number in front of my x, there's an invisible 1 there, so it's -1. We know that this is going to be a solid line because it has or equal to, and if it's less than, it is shaded below. My slope, my rise over run is -1 over 1. So it means down 1, right 1, 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 down 1, right 1. And then you could keep going if you want. I'm going to use my badge to sketch my line. We said it's solid. And we said we're shading below. Is there a solution set? That means, is there somewhere that is double shaded? No, there's nowhere that's double shaded. Is 0, 0 in the solution set? Well, first of all, there is no solution set because there is no double shaded area. But even if I did plot it, it's not in either of them anyway. But if there's no solution set, you're not going to have 0, 0 in the solution set. It doesn't exist. List one point included in the solution set that is not the origin. There is none. They're not double shaded. Okay. I'm going to flip to the back. Determine the solutions. It says whether we need to determine if it has one solution, no solution, or infinitely many. Write 0, 1, or many in the blank. If they are both y equals, plug that in your calculator. Go see where that crosses, row 1, row 2. So I'm going to go plug in y equals 5x minus 8. Y equals 5x minus 8. Oh, I wasn't even typing. Y equals 5x minus 8. And y equals -5x. Oh, They weren't both y equals, and y'all didn't tell me. Dang. Okay, so let me go back for a second there, because I just noticed they're not both y equals. This one's y equals, this one isn't. We have multiple strategies we can go about this. We can either use our substitution method, or we can change this to y equals so that we can plug it in. So I can show you both, just in case. If you're someone who likes the substitution method, in my class what I told them was box the one that's by itself, rewrite the one that we did not box. So y minus 5x equals 5. It says here that we know y equals 5x minus 8, so I'm going to change my y right here to 5x minus 8. Minus 5x equals 5. Well, 5x and negative 5x cancel out, so all I'm left with is negative 8 equals 5. Does negative 8 equal 5? No. If it is not true, it is called no solution. So we're going to write here 0. There's no solution for this. No solution. If you wanted to plug it in, let's say you're a calculator kind of person, y minus 5x equals 5. If you want to get the y by itself, the opposite of minus 5x is plus 5x to both sides. Y equals 5x plus 5. Now you could technically plug this one and this one in your calculator and go see if they cross. So y equals 5x minus 8, y equals 5x plus 5. These are two parallel lines. No matter where I look, these are not going to cross. It's called no solution. So either way, we still got there 0. There are no solutions. Okay. For this one, same thing. We can either use substitution or change it so they're both y equals so we can plug it in the calculator. If you're a substitution kind of person, box the one that's by itself, rewrite the one that's not. X plus 2y equals 14. Well, I know that my y has to equal 3x. So I'm going to change y to 3x. So we have x plus 2 times 3x equals 14. Well, now we got parentheses, we got to deal with these. We have x plus 2 times 3 is 6x equals 14. Well, now I need to combine my x's. I have 1x plus 6x, that's going to be 7x, equals 14. Divide both sides by 7, x equals 2. Well, if you can get x equals something, you're going to have a solution. There's going to be one solution, for sure. If you want to solve for your y, you would rewrite what we boxed. Y equals 3x. We know x has to be 2, so y equals 3 times 2, which is 6. So if you wanted the ordered pair, it would be 2, 6. So it has one solution. If you're someone who wanted to plug it in your calculator, I must maybe squeeze it up here. So we have x plus 2y equals 14. If I want to get the y by itself, we're going to do minus x to both sides. So we have 2y equals negative x plus 14. We don't want 2y, so we would divide everything by 2. So we would have y equals negative x over 2 plus 7. And then technically you could plug y equals 3x in and y equals this, and you should still be able to see that they cross. And if they cross, that means they have one solution. So y equals 3x. Y equals, we said it's negative x over 2 plus 7. Click on where they cross. They got 2, 6. That's what we got. And it doesn't actually ask us what the solution is. But that is the solution. All they cared about was how many solutions. It has one solution they cross. Okay. For this one, kind of the same wheelhouse. You can either change them both to y equals and then go plug them in, see if they cross. If they cross, they have one solution. If they never cross, it's no solution. If they are the same exact line and they are always crossing, we call that infinitely many. Or, on this one, we're not substituting because there's nothing that's by itself. But we can eliminate because we have a zero pair. We have opposites. If you're looking here, my negative 2y and my positive 2y cancel out. Then I combine what's left. Well, 1x, because if there's no number in front, there's an invisible 1. 1x plus 1x equals 2x equals 10 plus 14 is 24. If I want to solve for my x, I would divide by 2. X equals 12. If you get a number, we already know for sure we're having one solution. Ugh, my nose, y'all. Okay. Because if you get a statement that's not true, like we did over here, where it was negative 8 equals 5, that's when it's no solution. If you get a true statement, that's when it's infinitely many. If you're getting just one number, you're going to have one solution. If you wanted to solve for your y, even though it's not asking for it, you can always plug it back in. So we have 1x minus 2y equals 10. I know my x has to be 12, so 12 minus 2y equals 10. I guess I could take that invisible one out. If I want to get the y by itself, I need to do the opposite of positive 12, which is negative 12 to both sides. We have negative 2y equals negative 2. Divide both sides by negative 2. Y equals 1. So the point where they would cross would be 12, 1. Not that it, like, once again, it's not asking you for what the solution is. I know I solved it. It just wanted to know how many. If you wanted to, you could have changed them both the y equals, plugged them in, saw where they crossed. I really don't want to do it again. And I'm running out of room. Let's do it. Who would I be if I didn't do it? So that goes with that. I'm running out of room. I'm going over here. So we got 1x minus 2y equals 10. If you want to change it to y equals, so you can plug it in, we need to get our x to the other side. The opposite of positive 1x is minus 1x to both sides. Negative 2y equals negative 1x plus 10. Divide both sides by negative 2. We would have y equals, that would be positive 1/2, because a negative divided by negative is a positive, x plus 5. Y equals positive 1/2 x plus 5. You can't even see it. You can't even see it. Okay. Y equals 1/2 x plus 5. So then you can at least actually kind of see it for the most part. Okay. So there's that one. If I wanted to convert the other one, we got, split this one up again, my goodness gracious. 1x plus 2y equals 14. If I want to get my y by itself, I need to do the opposite of a 1x, which is minus 1x to both sides. So we got 2y equals negative 1x plus 14. We want to get the y by itself, divide it by 2. Y equals negative 1/2 x plus 7. Then I could plug both of those in my calculator and go see where they cross. Yeah. Talk to me. Thank you. Y equals, what is it? I already lost myself. 1/2 x plus 5 And y equals, we said, negative 1/2 x plus 7. They both do cross, so it means it has one solution. They cross at 2, 6. How did I get 12, 1, y'all? What did I type in wrong? Did I type something in wrong? What is this? What? Am I ding dong? No. Minus 1 divided by 2, negative 1/2 x plus 7. That's right. And then on this one, we did minus 1x. Negative divided by negative is positive 1/2. 10 divided by negative 2 is negative 5. 12, 1. I figured out my mistake. Not that it matters, so all we care is out just not asking for the answer. But I figured out my mistake. Hopefully y'all were screaming it at me that you saw it. We divided everything by negative 2. 10 divided by negative 2 was minus 5. And then I plugged it in. Okay. Yikes. 31 minutes. I'm still not even done. Okay. So on this one, they gave you y equals. So you have two different ways you can do this. You can either convert this one to y equals and then plug it in, go see where they cross. Or you can box and substitute in. I'm not showing both on this one because I've showed both on multiple of them. On this one, I'm just going to go ahead and change this to y equals. We got 3x minus 4y equals negative 12. To move the 3x, we're going to do the opposite. So minus 3x to both sides. Negative 4y equals negative 3x minus 12. I don't want negative 4, so divide by negative 4 on everything. Y equals, if I plug this in my calculator, it would be 0.75, which is positive 3/4 x. Negative 12 divided by negative 4 is positive 3. First of all, you should notice that these two are the same exact equation, which means they're exactly the same, and it's going to be infinitely many or all real numbers. It's called infinitely many solutions, IMS. It's also called all real numbers. These are the same exact line. I'll show you if you plugged it in. Y equals 3/4 x plus 3. Y equals 3/4 x plus 3. They're quite literally on top of each other. They're the same exact line. So we call that infinitely many or all real numbers. There's many solutions. On this one, if they cross, there's only one solution. If I wanted what that crossing point was, that would be at 3, 0. Like I said, they're not asking for it, but I'm writing it down. On this one, if you have two parallel lines that never cross, there are no solutions. We call that no solution. How many more left? 2 more on this side. All right. We have two equations in standard form. We can either convert all of these into y equals and then graph it, or use your cover-up method. Please, 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 please use your cover-up method. It makes this so much quicker. Y'all hating on the cover-up method, and it's going to save you time. Okay, so if I cover this up, I get 2x equals 30. Divide both sides by 2. X equals 15. We're going to have an x-intercept on 15. Great, it's not on the graph. Okay, and then for this one, we have negative 5y equals 30. Divide both sides by negative 5. Y equals negative 6. So we at least know we have a y-intercept at negative 6. We're going to have like an x-intercept somewhere over here. There it is. If I'm graphing this one, if I cover up method, I have 2x equals negative 10. Divide both sides by 2. X equals negative 5. So I'm going to go ahead and plot a point on negative 5 on my x-axis. If I cover up this one, I got 5y equals negative 10. Divide both sides by 5. We got y equals negative 2. Put a point on negative 2. I'm going to use my badge here to help me make my line. Great. My line's probably not really accurate. I mean, it's really close to 4, negative 4. What's the answer to that one? I want to know. Nope, it's not on that paper. Dang it. I just wish I could be more accurate. Okay, then here's what I'm going to do. Because I'm not sure how accurate my line is. If you remember, to figure out your slope from standard form, it's opposite of A over B. That's how you find slope from standard form. A is a number, it's ax plus by equals c. So if I'm looking here at this first equation, because that was the one I wasn't sure if I graphed right, what's the opposite of positive 2? Negative 2. Divided by my b is negative 5. Negative 2 over negative 5 is positive 2 over 5. What? The frick? I mean, what is going on now? Shouldn't it be negative? Opposite of A, 2 minus 2 divided by 5. Did I plot this wrong? Oh, because I'm looking at the wrong line. This, okay. So that means we go up 2, right 1, 2, 3, 4, 5. Oh. Up 2, right 1, 2, 3, 4, 5. Oh, my line was so off. Okay, I fixed it. Okay. So now that I fixed my line, I was definitely not correct. They cross here at 5, negative 4. Goodness. So yeah, that one, as much as I like the cover method, it's great. But 15 wasn't on my graph, so I couldn't really make an accurate line. So I did my negative, or not negative, it's opposite of A over B to figure out my slope, and used my rise over run to help me figure out that line. Last one, and then I'm quitting for today. Not quitting, but like, I'm tired, y'all. I've recorded 2 videos. This is my 3rd one today. Okay, let's try cover up method first. We have x equals 24. We have 4y equals 24. Divide by 4. Y equals not 8, 6. 6. So even though I can't plot the 24 on my x-axis, I know I can at least plot the 6 on my y-axis. Because the x is not on this graph, I'm going to go ahead and use my slope formula for this one. So m equals opposite of A over B. Ax plus by equals c. If there's no number in front of our x, it's 1. Well, the opposite of a positive 1 is negative 1. And then my b is 4. So my slope is negative 1/4. So I'm going to go down 1, right 1, 2, 3, 4. Down 1, right 1, 2, 3, 4. And sketch in my line. All right, if I do it on this one, cover-up method, I have negative y equals 3. There's no number in front of my y, it's a 1, so it's a negative 1. Divide both sides by negative 1. Y equals negative 3. So I'm going to go ahead and plot a point on my y-axis at negative 3. If I'm looking here, I'm going to have 2x equals 3. This isn't going to give us a nice one. That's fine. We have 2x equals 3. Divide both sides by 2. X equals 3/2 or 1.5. So we're going to have a point on my x-axis at 1.5. If you're worried about that not being really accurate, which I'm worried about my line not being accurate again, I'm going to use my opposite of A over B. Okay, so if I do opposite of A over B on this one, my A is 2, so the opposite of positive 2 is negative 2. My B, if there's no number from my y, is 1, so it's a negative 1. Negative 2 divided by negative 1 is positive 2. So my rise over run would be 2 over 1. So it means I'm going to go up 2, right 1. Up 2, right 1. Oh my gosh, I can't see. 1, 2, 1. Up 1, 2, over 1. Up 2, over 1. So definitely using my opposite of A over B when I'm not quite sure really helps out make sure my line is accurate. So where they cross is right here. That's at 4, 5. Oops. I know I need to fix my nails. You don't gotta tell me. All right. I'm calling it quits there, y'all. Good luck.